video, we're going to look at solving a system of linear equations using the inverse matrix. So in this video, you will need a technology. You will need a graphing calculator or regular I don't know if a TI-30 would do this, but you will need some type of technology that can handle matrices. So we're going to first start out with a x, y, and z system of equations. And in this case, again, we have the x, y, and z that we're going to place into a matrix. So first, let's get this into a matrix. So my x coefficients will go in the first row. My x coefficients are -3, -1, and 2. Next is my y coefficients. I do have 1 here in the third one, which is -1, but I'm lacking at 2 in the upper two equations. So those will be substituted. No, just gonna use substitute because I cannot placeholder. Those will have a placeholder of 0. And then the last one are my z's, which is 1, 2, and again in this last equation we have no z's, so that's going to be a 0. Okay, we're going to multiply this to the x, y, z to keep up with form. Again, writing it this way, we do end up getting the system of equations if we multiply this out, and we do get it equal to -9, 2, and 10. So first things first, what I'm going to do is I'm going to go over to my technology. I'm going to use it, and I'm going to find the inverse function of this guy. We're going to call him c. So my inverse c, I guess I could have just called that a for my graphing device, but I came up with just c. And the inverse, after putting the variables into the calculator and finding my inverse, and I'll attach that video at the end of this so you guys know how to use the TI-84 to find this. And I'll do exactly for this problem as well, just using the graphing device. Although I've made many of these videos and I've edited some videos for other classes, I have not edited a video for this, nor do I find that I might have time for this. Alright, so we're going to have the inverse c, then we're going to have the matrix c. This is multiplied by our matrix, we're just going to call that matrix x, and this is going to be equal to, I don't know why I'm putting parentheses, the inverse c times, I'm going to call this s for our solutions. Alright, so when I do this, these two matrices produce the 1, 0. So when I multiply these two, I'm going to get that 1, 0, 0, 0, 1, 0, 0, 0, 1 matrix. And then what I'm going to do is this is going to be multiplied by x, y, and z. Because we still have that right here, so that's there. And this is going to be equal to -0.4, 0.2, 0, -0.8, 0.4, -1, -0.2, 0.6, 0. Times -9, 2, and 10. Alright, so if you need to take a moment to write this down, write it down. We're going to go to the next step, and we're going to start with a clean page. Okay, so now on the left-hand side, when we do that multiplication, we're going to get x, y, and z. On the right-hand side, we will get the values of a -0.4 times -9 plus 0.2 times 2 plus 0 times 10. Then the next column times the row is going to be 0.8 times negative 9 plus 0.4 times 2 plus negative 1 times 10. Next row is going to be row 3 times the column 9 to 10. So this is going to be negative 0.2 times negative 9 plus 0.6 times 2 plus 0 times 10. And there's that matrix. When all said and done, we will get xyz is equal to 4, negative 2, and 3. So in other words, the solution is x equals 4, y equals, that's not a y, that's an x, I just wrote x a second time, y equals negative 2, and z equals 3. Alright, so that was a nice clean matrix. Let's try another matrix. Let's try the system of equations with some fractions. And not all fractions end up like this. This one just happens to be this fraction. So x minus 5/8y equals 1/2. And then the second equation in the system of equation is going to be negative 2x plus 5y equals negative 4. Okay, so this is a 2 by 2 matrix. It's not too bad for finding the inverse. So I'm going to do the inverse in this one by hand. I'm going to find the determinant first, and that's 1/4. xy equals 1/2 negative 4. Okay, so I'm going to find the determinant. I'm going to call this matrix A. You could do this in a calculator if you like. But remember, for a 2 by 2 matrix, we're going to take the determinant of A, which is equal to 1/4 times 5. That's not an equal, minus negative 5/8 times negative 2. Here we get 5/4 minus here we get 5/4. So we get 0. So if we have a determinant of 0, this has no inverse matrix. So we cannot solve this system of equation using an inverse matrix. We're going to have to go to another system, another way to solve this. So I'm going to do, I think what I'm going to do is elimination. Because what I could do is I could identify that if I multiply this top one by 8, we get that 5, and we get the 8 taken away. So that's what exactly I'm going to do. I'm going to multiply that whole thing by 8. 8/4 is going to be 2x. This one is going to be minus 5y. This is going to equal 4. Well, if I bring down equation number 2, I get negative 2x plus 5y equals negative 4. And essentially, these become 0, so we get 0 equals 0. And this means that we have infinite amount of solutions. Alright guys, so this is the end of the video. If you have any questions, and again, this is particularly to this problem. Not all problems are going to be like this, but this is an example of this exact problem. Guys, if you have any questions, always feel free to ask, and I'll catch you in the next video.